In this video, we are going to look at integration of exponential functions. Using the fact that we already know that the derivative of e to the power of x is e to the power of x, we will know that the integral of e to the power of x dx is going to be the function itself plus a constant. If we have to differentiate e to the power of x multiplied by a constant c, then we know that their derivative is going to be c times e to the power of x. Using again the same fact that integration reverses the operation of differentiation, so we know that integral of c e to the power of x dx is going to be c e to the power of x plus c. In the same manner, if we have to differentiate e to the power of ax plus b, we know that the derivative is going to be e to the power of ax plus b multiplied by the derivative of the internal function, which is ax plus b, and that is a. So therefore, the integral of e to the power of ax plus b dx is going to be 1 over a, because we have to compensate for that a that will come from the differentiation, alright? So it's going to be 1 over a times e to the power of ax plus b plus c. Here are some examples. If we need to integrate e to the power of 3x dx, the answer is going to be 1/3 e to the power of 3x plus c. You can check if you differentiate this function. Differentiating e to the power of 3x gives you e to the power of 3x times 3, and dividing by 3 gives you back your e to the power of 3x, plus of course a constant c. In the same manner, integral of 2e to the power of minus 5x dx will give you 2 at the front because of this rule, and 1 over the constant that you have in the index times e to the power of minus 5x plus c. Alright, let's look at how to integrate an exponential function in which the given base is not e but is a. So the base must first be changed to e. So let a to the power of x now being written to the base of e. So our index is going to be somehow z, and we need to find that z. Taking logs to the base e, we have x ln a equals z. Therefore, that a to the power of x, which is e to the power of z, is going to be e to the power of x ln a. That's because that's what we have found, that z in fact is x ln a. Okay, therefore coming back to our original question, what is the integral of ax dx? We can change our a to the power of x. We can change to the base e, and we can write e x to the power of x ln a dx. As you can see now, we've got our standard integral where instead of constant in this index part, we have our constant ln a. A is a constant, so ln a is a constant too. So following the standard rule, we'll have our constant taken out of integral, only we have to divide by that constant. 1 over ln a times e to the power of x ln a plus c. So here is our result that we are going to use in the next examples. So we could come to the same result using the fact that we know actually that the derivative of a to the power of x is ln a times a to the power of x. So therefore it follows that 1 over ln a, let's divide everything by ln a, times the derivative of ax by dx is a to the power of x. So the integral is going to be a to the power of x divided by ln a plus c. Now pause the video and try some of these examples, that all of them you need to integrate with respect to x. Here are the solutions. So if I need to integrate e to the power of 2x dx, I understand that, alright, we have constant here in the index form. So therefore, my answer is going to be e to the power of 2x, but I have to divide by 2 to compensate for that 2 that will come out after differentiating e to the power of 2x, and plus a constant c. We always could use actually substitution method. Look, I can replace my 2x with a new variable u. Therefore, differentiating both parts by dx, we are getting du by dx equals 2. So therefore, du is equal to dx, and therefore dx is equal du over 2. Or simply, we can multiply, we can change this variable x into 2x, but of course we have to divide by 2 to compensate for this 2. So we have now e to the power of 2x by d2x over 2, and here we are getting our result easily, okay? So here is another example. Integral of 3 times e to the power of minus x dx is going to be 3 goes out of integral immediately, and then we compensate for this minus 1 by getting minus 3 times e to the power of minus x plus a constant c. Here's one more example where we have integral of e to the power of 4x plus 1 dx. Again, we are getting the same e with the index 4x plus 1, only we have to divide by 4 and to add a constant c. In the same manner, following the same procedure, we are getting all other examples. Look at this. We're dividing here by ln 2. Here we are getting ln 3 because of this base is not e. Alright, but also we have to divide by 2 to compensate for this 2. And the same with the following example. Let's see other answers. So here is integral of square root of e to the power of x dx. Again, we can write this square root of e to the power of x as e to the power of x over 2, and that's how we've got this 2 at the front. In this example, don't forget to change 1 over e to the power of 2x to e to the negative 2x. That's how we are getting minus here, minus 2x then. Alright, and there is nothing really new in the last example, only remember that integral of the difference is going to be the difference of two integrals, and so you integrate each of them separately. That's it. That's the end of the lesson. Thank you for watching.